Well, hello everyone. This is Eric Chappell, Civil Community Evangelist for Autodesk, and I'm very pleased to have today with us for this webcast Mr. Eric Bill from Impact Infrastructure, and also from Impact Infrastructure, Mr. Ryan Myers. And these two gentlemen are going to be talking to you about AutoCASE, one of our partners, and how it's used to integrate a cost-benefit analysis into the design process. They're going to talk about that and a lot more. Before we get into our stars of the show today, I want to talk a little bit to you guys, though, about our webcast series. I know some of you are veterans and have been attending for over a year now, but we also have quite a few new people each time, so I like to talk about what we do here. We like to do this about twice a month on the first and third Wednesdays of the month. Sometimes our schedules cause us to shift some things around, but I think we're sticking to that pretty well this month. And our goal with this is to give you information about our civil product features from the perspective of the product team. So we know that you hear from us a lot from our marketing folks and from our sales folks, but we want you, the users, and we know that primarily in the audience for these webcasts we have users of our software. We want to address you on a more technical standpoint and a little more directly from our product team. Now, we've got a special treat today because we've got our partner with us, Impact Infrastructure, and that's an even better insight into one of the tools that enhances our software even more. So I'm really excited about this kind of special edition of our webcast series. Speaking of the series, next up on Wednesday, October 5th, we're going to be covering InfraWorks 360 component roads and super elevation. If you haven't yet installed the latest release, which came out earlier this month, you'll find component roads and super elevation in that release. And these two features alone have greatly elevated the power and functionality of InfraWorks 360. So you definitely want to check these out, and you definitely want to tune in to our next webcast to learn about not only how they work, but kind of what was the product team thinking as they developed these features. Why did they do what they did, and why did they focus on certain things first and maybe save some other things for later on? So it's a really great insight. Information on that webcast will be coming out on the different channels listed on the bullets down there, the community site, the forum, and also social media, Facebook, Twitter, and LinkedIn. So make sure you watch those closely. And if you've attended a previous webcast, you will also get an email announcement of the upcoming information on upcoming webcasts as well, which you can opt out of if you don't want to receive those emails anymore. Before we continue, I also wanted to do a few polls. Again, our veterans will be familiar with these polls. So the first one has to do, actually we're only going to do one poll today. It's, what is your current usage level with InfraWorks 360? So ranging from I don't even have it installed to I use it on almost every project, couldn't live without it. We're interested in today's audience what your usage level is of that product. So if you wouldn't mind providing your answer, we would love to hear from you and just get a little information about where kind of where the world is on InfraWorks 360 adoption. If you're curious about how the answers are rolling out, our leader at 32% is I've dabbled in it on a few projects. Tied for second are I've installed it and played with it a few times, and I regularly use it on some projects. And then next after that, use it on every project, and coming in last is I don't even have it installed at 9%. So some interesting results there. We definitely have a curve going on, a bell curve, with the highest number of you being in the middle, having dabbled on it in some projects. So I'm going to go ahead and close that poll, and I want to talk to you about our InfraWorks 360 community. You definitely want to check out the URL on your screen, autodesk.com/InfraWorks360 community. We've got kind of a one-stop hub here which links you out into all the really valuable resources that relate to this product. And just so you know, and so you can watch this happen, we're actually broadening this community site to include not just InfraWorks 360, but all of our civil products and our partner products as well. So Things like the forum, idea station, info tips, the gallery, these are all currently related to InfraWorks 360, and they will soon broaden out to Civil 3D and other products. And actually the gallery is a civil infrastructure gallery now, so it does include both products already. So we're slowly rolling out this broader approach to community, and you definitely want to keep an eye on this page as we do that. Videos, tons of videos on the hub, including recordings of all of our previous webcasts in this series. And we've been doing this series now for a year and a half, and so far, knock on wood, I have yet to forget to record a webcast, so we have a complete library of all of our previous webcasts in this series posted up to the community site, as well as lots of other cool videos as well. So you definitely want to check out the community hub. I don't believe this disclaimer is going to apply today, but sometimes we talk about preview features or labs features, things that we're working on or we're planning on maybe bringing out in the product in the future. We just have to legally state that one, unless you actually see it in a future product, there's no guarantee that it'll be there. And most importantly, don't make any purchasing decisions based on anything that's tagged as a preview or a labs feature or something that we're working on for a future release. We encourage you to ask questions. Eric and Ryan are our experts today. I admittedly know very little about AutoCASE, other than that I've seen the awesome things that it can do, but from a technical standpoint of answering deeper questions, I'm going to really rely on those two guys to kind of support each other and to encourage you, the audience, to ask lots of questions. Questions make the presentations even more interesting, so please, if you've got something on your mind, go ahead and type it into the questions panel in your GoToWebinar interface. Unfortunately, we can't open the phone lines because of the size of our group. It would sound like pandemonium. So we have to rely on the questions pane. But I've encouraged Eric and Ryan, if something of particular interest comes up or if there's a recurring theme, to please say that out loud so all of you can get the benefit of that question and answer as part of the presentation. And I think we are about to start. So I'm going to turn over the floor to Eric, the other Eric on the call, and he's going to kick you off and talk a little bit about AutoCASE. Eric, the floor is yours.
Eric, thank you. Thank you very much. So it's a special treat to be here. Thanks to everybody for joining us today. Today we're going to talk about probably a few things that you don't normally get to hear about, which is economic analysis for infrastructure projects. We're going to be speaking directly to green stormwater infrastructure, or GSI, today. So that's really the theme. And we're going to be talking about sort of broadly some economic analytical concepts within business case decision making and bringing some additional analytics to making sustainable decisions in infrastructure. Our software, as Eric mentioned, is called AutoCASE. Right now we've got a beta module out for green stormwater infrastructure, soon to be released beta for sustainable buildings, and our firm is Impact Infrastructure. So we are a partner with Autodesk, and really our goal for the firm is to create a standardized suite of automated business case tools for infrastructure assessment. And so our firm is made up primarily of economists and computer programmers, just to give you a flavor of the world it is that we exist in. So that's really a bit of background on our firm and some of the topic today. I think just a little bit more background on the discussion today. I think really wanted to bring forward just the concept of business cases and using economic analysis in different ways to inform the design of more sustainable GSI and broader set of infrastructure design. We're talking a little bit about decision-making frameworks within that economic lens towards infrastructure. A key concept of what we'll be talking about today is triple bottom line. I think we're all well versed in this area, but this is really the economic or financial, social, and environmental impacts to infrastructure. And we'll be discussing some of the data considerations in building these business cases and delve into some demos within AutoCASE that Ryan's going to lead us through. So just a little bit of background here. And so business cases, let's talk about sort of some of the traditional means in which infrastructure investments in GSI are assessed. And I'm going to sort of bring us up different levels of business cases, different considerations in economic analysis that really leads to robust analysis. And a lot of the folks that are part of our firm are former economic and financial consultants in the infrastructure world. So working with clients on a custom consulting basis to conduct business cases to help provide additional information to make better decisions in project prioritization or project design, or really just to use the business case as a means in which to provide this objective proof that the decision that was made is the right decision, for example, or to help tie into capital planning. And so business cases, have a long history in making decisions in infrastructure. And I just want to talk a little bit about the traditional means in which a business case is made. So traditional financial analysis, we're going to call it. And all this is just some background to lead us into AutoCASE software and the demo that Ryan's going to provide. And so brief background here. So we're talking about traditional financial analysis in the sense that a business case is made for your own organization when you're looking at a particular investment, say in GSI, you're looking at your financial costs and revenues here. So a traditional financial analysis, we can see these different line items, and these are outputs from AutoCASE, and we're going to see different line items added to represent different sort of complexities and rigor in these business cases. And so right here in this traditional financial analysis, we've got our capital expenditure, so what it costs to invest in this GSI. We've got our ongoing operations and maintenance costs, decommissioning costs, and any subsidies. So, this is really just some typical financial impacts. And we see this column called value here. And so that's the present value of the business case and the different impacts in this case projected over a future study period. In this case, it could be 25 or 30 years, and then discounting those future cash flows to current dollars to get us one value that represents the net impact of each of the cash flows. And so in this case, the GSI set of investments here has a net present value, so the sum of these cash flows of about $18,000. So it's costing us an additional $18,000 to invest in these GSI designs. And so we're calling it a no-go because that represents incremental cost. And if you're using traditional financial analysis, the decision might be made that, oh, it's too expensive and let's forget about it. Let's talk about a few challenges with some of these financial analysis concepts. I think sort of what comes up the most are projecting data, so projecting the various considerations in our business case, trying to get accurate cost estimate information, and try to get data that is very localized. I think that's a challenge in conducting different estimates in different locations. And some solutions that we found, so certainly the conversation today is around BIM and different sort of data considerations, GIS, so Civil 3D, InfraWorks 360. Our goal with AutoCASE is to tie in within the design suite to be able to extract some of the data created within these suites, and we're every day getting closer to that goal. Right now, AutoCASE is sort of a standalone browser-based product, and going forward, the goal is to tie into Civil 3D and InfraWorks 360. Eric provided a bit of the details around InfraWorks 360 and some roadway analysis. We use InfraWorks 360 to analyze, say, freight rail and other grade separation investments where we can extract some of the data relating to delays and VMTs, so on and so forth, that help us create very site-specific economic analyses. And so really I think the solution is using these great BIM and GIS-related design suites to help conduct a more rigorous and accurate economic analysis. And I think what is missing in a traditional business case is that GSI and green designs versus gray infrastructure, there are a multitude of benefits that come out of them, but financially speaking, we know that they have a longer life in many occasions, different design considerations. So porous asphalt, we've got a 30 to 50% longer useful life than typical asphalt. You know, we know by tracking longevity of green roofs that they can last twice as long as a gray typical membrane roof. So we've got these broad impacts that aren't typically included in that traditional business case. And so this next stage of analysis is life cycle cost analysis. And I'm sure you're all familiar with this concept, but you know, we don't actually see this kind of analysis being done widely in the infrastructure space. And you know, this is sort of a best practice just in the financial analysis space. And so life cycle cost analysis is taking this long-term view and looking at the upfront capital costs, the ongoing operations and maintenance, plus taking into account the replacement costs and the residual value and the differences in green versus gray infrastructure. And so we've added a few line items to this business case and added the replacement costs and residual value of assets. And so when we add these additional considerations into the business case, we have more information that can help us make better decisions. And so we've got a better net present value here. It's about $12,000. So it's still a net cost, but it's 35% better than that previous assessment, just looking at the upfront capital costs and the ongoing operations and maintenance. And so I think a big consideration in infrastructure is the concept of public works investments and public benefits. And so we've seen the financial side of a business case and using life cycle cost analysis to provide additional information. But a key consideration in infrastructure is externality. So this is the concept of investing in public infrastructure. It tends to provide these additional broader social and environmental benefits called externalities that aren't typically assessed in a business case or typically assessed qualitatively. And really best practices in infrastructure business case decision making is cost benefit analysis. And I'm not sure if that is a widely known term amongst some of the attendees here, but cost benefit analysis is really the gold standard in business cases and economic analysis for infrastructure decision making. And it's really taking the full broader lens towards quantifying and monetizing, putting a dollar value to these broader externalities and impacts that are generated because of infrastructure. And if we think about specifically GSI, there are a whole broad set of benefits that are being provided from green stormwater infrastructure versus gray that we want to account for and incorporate into the business case. And we're using cost-benefit analysis techniques, methodologies to do that. And really that's the crux of AutoCASE in automating the kind of cost-benefit analysis that was typically only done from a very expensive custom consulting point of view. And so, you know, we've got this Venn diagram. We've got the economic, social, environmental impacts. This is the triple bottom line. And cost-benefit analysis lends itself very, very well to analyzing this whole concept of triple bottom line impacts, because we're able, using peer-reviewed literature, using statistical data, really rigorous, objective background information on the benefits of GSI and other infrastructure systems, and we're incorporating that into the business case in an automated fashion. And so, you know, this concept of triple bottom line really is all about understanding the trade-offs, the financial trade-offs between social and environmental impacts, and taking this long-term view to help really understand what the broader impacts are, costs and benefits of your investment. And so we've got a lot of numbers here. Really, this is a view of this triple bottom line cost-benefit analysis. This is a whole suite of outputs from AutoCASE on a hypothetical assessment. And we've got the same cash flows that we had previously in the life cycle cost analysis, capital expenditures, operations and maintenance, the decommissioning costs. But now we've got many of the benefits that are incorporated into this business case that are being generated because of these GSI related investments here. So we've got impacts related to greenhouse gases and criteria air contaminants. So this is through sequestration, absorption of these emissions. So we've got benefits associated with that. And in cost-benefit analysis, what we're doing is we're taking data on, say, how much of carbon and criteria air contaminants that are absorbed and sequestered through different vegetation. We're getting that quantity data, and then we're using peer-reviewed literature to value what the ecosystem service impacts are, so the real externality costs or benefits of these impacts. And so we're applying these dollar values to each of these impacts. And I think it's a really great way for stakeholders to understand the impacts of green infrastructure and really get a better sense as to what the impacts are, rather than just anecdotally. And so we've got the carbon and air contaminant impacts. We also have heat island effect impacts because of evapotranspiration, increased shading of GSI. We can calculate the impact in a reduction in heat risk mortality, and there's many different pieces of literature that's backing this evaluation up. We've got property value impacts. We know that there are hedonic pricing analyses, so analyses that compare the location and the type of green stormwater infrastructure investments to prices in housing and residential real estate. And so by investing in GSI, you can generate property value enhancements. You can also reduce the risk of flooding. For example, and Ryan's going to get into some of the details in AutoCASE, but calculating these additional impacts of flood risk reduction because of a reduction in infiltration rates, for example, or some other considerations that can reduce what the historical flood risk opportunities are or costs associated with flooding in a specific area. And it's all very site-specific, taking into account local precipitation and weather data, local property values, and very site-specific information. And so really that's just the broader cost-benefit framework here. So now we have a much more holistic business case that assesses a lot of these intangibles that we know are being generated by GSI, and now we've got a means in which to incorporate it a little bit more operationally into decision making. And so the project now, you can see down here, is a go because we've got a positive net present value. So that means the benefits are greater than the cost of this project. It's a small amount, but it's still something that provides additional information to help make decisions. So we've got a few challenges that we want to discuss with this kind of triple bottom line cost benefit analysis. So I think it stems from a few different areas, and of course some of these areas are improving and we're seeing some impacts, but reliable studies and approaches, we're really at the mercy of what's being produced by federal agencies, by other levels of government, by academia, NGOs, etc., that are producing these kinds of very rigorous peer-reviewed studies that provide the data that feeds into these kinds of analyses. There are different methodologies employed in assessing the same kind of impacts, and that can be a little bit challenging for economists to use and apply to projects. And we've got sort of different perspectives on the kind of data that's relevant for different kinds of impact evaluations. And I think some of the solutions here, what we're seeing in the market is that there's real focus now on producing information to inform cost-benefit analysis. It's a widely used approach, and it's used by all federal agencies for any proposed regulatory changes. So there's a lot of information out there that we've amassed and built into AutoCASE, for example. And we've got a lot more of these automated tools coming to market, including AutoCASE, but also some of these other systems like Triple Bottom Line Tool, Safari, and Edge that are partnering with large organizations, us with Autodesk, for example, to really get best-in-class tech behind us and be able to integrate into some of these great design tools. So I think just before I hand it over to Ryan, I think really the concept of triple bottom line analysis is that this kind of cost-benefit approach really translates some of these esoteric impacts into something that people recognizes, which is dollars and dollar value impacts. And so it really gives us a whole suite of benefits to help communicate with our stakeholders on projects and really to help design more impactful infrastructure given this kind of analysis. And so we've talked about sort of the traditional financial analysis, the enhanced business case incorporating life cycle costs to them, and then really the pinnacle here, which is triple bottom line cost benefit analysis techniques to really provide the most information on the outcomes of your designs. So Ryan, or Eric, I think it's time for Ryan to jump in here and take us into the world of AutoCASE.
All right, Ryan, the floor is all yours, so take it away.
Great, thanks guys. All right, so I'm going to demo two different projects to you today. So I'm going to show you one that's a redevelopment of a brownfield in St. Paul, Minnesota. So that's a Ford site redevelopment project that's currently in the planning stage and is striving to be one of the most sustainable developments in the country. And the second project I'm going to show to you is a green roof project for a New York City transit building that's going on top of a LEED certified building, and I'll show you how that analysis led to supporting that decision. So what I've done here though is I've logged into the platform, so I'm just using a normal browser. So you know, this is easily accessible for anybody. So I'm in Google Chrome right now, and I've just gone into this project, the Ford site stormwater centralized project, and I'm going to go into one of the design alternatives here. So I've got a couple design alternatives, and I'm navigated to the inputs page. So one of the common questions that I get from people is how many questions do I need to answer in order to get a triple bottom line analysis run on my design? And the answer to that is very few. The only input that we really need is the location. So this is one of the things that Eric touched on, which is that you know, it's tough to create generic methodologies that are then location specific and particular to your project. And so what we do is we draw upon a whole bunch of location specific data that then feeds into our methodologies. So we look at city or town population, population density, we look at weather information, exposure to sunlight, rainfall, temperatures, salaries, all kinds of stuff that's feeding into the methodologies. So when you actually analyze the same project across the country, you can get totally different results. So the first piece of information we really need is the location. The second piece of information is, of course, design feature information. So in this design, we've got a recreational park, we've got a pond, we've got a rain garden, and we've got a couple other elements here as well. Now, just to show you how easy it is to kind of create a design feature, I'll just sort of add some additional trees in here. And so I'm just going to say new patch of trees, and I'm going to add 30 trees in here. And then there's a whole bunch of other inputs that are all defaulted. So you know, I can talk about the diameter at breast height of the trees or the expected lifespan. I can even modify the infiltration rate, so I can talk about the different soil types, or even input the infiltration rates manually here. And then finally, one of the things that's pretty valuable, especially for this kind of project that's in the planning stage, is that AutoCASE also provides cost estimation. So if you have no idea what the costs are going to be for something, but you do have several different design alternatives, you can actually at least get a ballpark of how much that's going to cost and what kind of picture that's going to create. So I'm just going to click Add Feature, and then it's been added up here. There's a new patch of trees. So when I'm ready to run, that's basically it. There's room for a bunch of other inputs. So if you want to input information around subsidies or revenues or wetland characteristics or energy usage, we've added a lot of depth to this application so that you can go as deep as you want to go in this cost-benefit analysis. But really, it was all about, okay, how can we turn cost-benefit analysis and triple bottom line analysis into something that's really easily doable for anybody, for any designer, architect, or engineer. So then I'm just going to run the analysis here. And this is actually running an entire Monte Carlo simulation, which basically means it's taking uncertainty into account rather than giving a point estimate. And so then I'm navigated to the results pages, and I've got kind of 3 different levels of results that go from the simplest level to increasing levels of detail. So the first page is just an executive summary here with some auto-generated text that tells me about my project and about the largest costs and benefits. But really, I think the core value proposition of the software is around monetizing or putting a dollar value on the intangibles, or as Eric said, internalizing the externalities. So in this example, I've got a whole bunch of social and environmental costs and benefits here, and you can see this is very similar to the slide that Eric showed earlier. So I've got the value of each of these costs and benefits, as well as the range of uncertainty that surrounds that value. And something else that I want to show is that a lot of this is new to people. Our users often know that this is important, but they're not experts in this space. And so there's tooltips next to each of these that give an idea of what this methodology is, what this impact is, how it's being calculated, what the sources are, and then a link to our documentation. So I want to pause there for a second and just talk about our documentation. We've got everything kind of fully documented on a different website here. So we've got all of our methodologies for all the inputs. So for example, we actually look at flood risk mitigation. So if you're putting a rain garden next to a parking lot, that of course can have flood risk mitigation value, as well as reduce the costs of piping or any required on-site detention. And so we have this methodology here laid out very clearly. So if you're not an expert in this space, which most people aren't, you can actually go through here and see exactly what's happening. And if you're actually an engineer or an architect running a project for a client, you can easily kind of skim through this and be able to explain to your client what's happening. We've got a whole bunch of other results categories here. I'm not going to dive into all of these, but just to give you a kind of sense of this, we also look at quantified results. So of course, a lot of people are concerned about carbon footprint and how much sequestration is taking place. Of course, stormwater management is always front of people's minds. So here we look at the total infiltration and retention capacity of all these different design features, as well as the stormwater diverted in the site's design storm for each of these features. This one I'll touch on life cycle cost analysis. So this gets to that second level of the pyramid that Eric showed, which is around looking at the life cycle cost of each of these design features. So we don't just look at capital expenditures, because that only provides one slice of the picture, one piece of the picture, but we also look at the life cycle operations and maintenance costs, as well as the replacement costs over time, and if relevant, the residual value of assets at the end of the operating life of the project. We can also break down the results by stakeholder value, and this, of course, can be useful for creating stakeholder engagement, which as everybody knows is very important. So that's kind of the first project. I know I went through that a little bit quickly, but I'll go through a second project now to kind of reinforce this. So
Ryan,
I'm going to show you.
Could I just jump in for a second?
Yep.
Thanks very much. Just to provide a little bit of context on that particular project. So as Ryan mentioned, it was a urban redevelopment project on the former Ford site assembly plant right on the banks of the Mississippi, right in the heart of downtown St. Paul. So just an incredible urban site that you know, is going to be the future redevelopment of a major sustainable development mixed-use community. And so we're working with the city of St. Paul and some of their design firms to analyze the stormwater system as well as the transportation round plan. And these analyses that we're engaged in right now are to help inform the public policy around the redevelopment. And when we conducted the analysis, we had two scenarios. So Ryan took us through one of the design scenarios for the stormwater assessment. And so we're looking at different designs to help inform the building and development policy around the site, because it's privately owned and it's going to be sold to a private developer. So the city wanted to have you know, a conversation with the various owners around how to develop this site using different analyses, one of which is the outcome from this AutoCASE cost-benefit analysis. And when we looked at these two different design scenarios, the first was really just a bare bones GSI type scenario where we're looking at some distributed systems. And the second alternative is really a centralized focus, much greater concentration of GSI that tied into a recreational space. It tied into some wetlands, and it tied into this beautiful set of falls that is really a reflection of the hydrology on the site. And when we did the analysis, we found that this second, more strongly focused GSI site had about $4 million more in life cycle costs, but it generated $12 million more in benefits. And so it had 2 times the benefit cost ratio than sort of that first sort of base level design. And the firms that were engaged with the city really used that to help provide recommendation towards a more GSI-oriented site design rather than sort of the bare bones features. So that's just a little bit of the context that I wanted to share. Ryan?
Great. Thanks, Eric.
If I can chime in here, we did have one question about applicability to Europe. Is this a U.S. only product, or can it be used elsewhere?
Great question. Currently, we've got 550 cities in the model. They're U.S. and Canada only right now, but we're looking at expanding to other areas as well, including Europe. We're just not quite there yet.
By the way, we're 100 Resilient Cities Rockefeller Foundation platform partner, and so a number of those cities, it's a global arrangement, so a number of those cities are outside of Canada and the U.S., and so we're looking to take the opportunity of being part of 100 RC platform partnership and build up the additional intelligence if there's enough interest from the global market for this kind of analysis. And you know, we're really at the mercy of the literature that exists in the market, and we're starting to amass some of those global data as well.
Yep. So I'm going to jump into the second project now, unless there are any other questions. I haven't been checking the question bank. So interrupt me if there are. But so this one that I'm going to show you is a green roof in New York City. So this green roof was put on a LEED certified building, and they wanted to run a business case on it to support the decision for putting the green roof here. So this is a much simpler design than the last one. We've just got a green roof and a cistern up there as well. So if I click edit here, I can see we've got a 1.2 acre green roof here with about 4 inches depth of coverage materials and about 30% empty space. And then they've input their own capital expenditure estimates here of about $900,000 and about $47,000 a year in operations and maintenance costs. So one of the things that I want to mention before I run this analysis is there's 2 different ways that you can run an analysis. One is just to look at the absolute value of something, and the second is to look at the relative value of something. So just to give you a quick example, if I was to analyze the value of, or the carbon sequestered by a tree, just throwing out a number, that might be 1 ton per year. But in the next best design alternative, if there was going to be grass there, and that might be sequestering 0.1 tons per year, then the change, the incremental amount, is actually only 0.9 tons. And so there's 2 different ways that you can frame these analyses. The first is absolute, the second is relative. And so we allow the users to kind of pick or choose whichever one they want. So I'm going to run this analysis as an absolute analysis first, just to kind of demonstrate how this works and why it's important. So again, navigated to the executive summary here. And on the project summary, we've got an even larger list of costs and benefits. And what I'm going to highlight here is under the summary financial metrics, we've got the net present value, total sustainable median. So this, it looks like it'll cost about $1 million to analyze, or sorry, to put in this green roof. So this is obviously a negative value. Now, if I go back to the inputs here, and I'm just going to, so I've just gone back to the inputs page, and under Run Report, there's a little drop-down arrow, and I'm going to select Relative Report. So this is now comparing the green roof to a gray roof. And I know this if I go to Design Components and click on the green roof inputs here. At the bottom of the page, I've got alternative feature type, and gray roof has been selected. So in other words, if they don't put the green roof on this building, it's still going to have a roof. And so I'm just going to run this report now as a relative analysis. Just give it a couple seconds. And I know there were tons of numbers here before, so it's tough to see that they've changed. But if I go into the summary financial metrics again, I can see that this actually has a positive sustainable net present value now. So in other words, where this looked like it was going to be costing $1 million before, we weren't really taking the whole, the next best design alternative into account. So when you actually compare the green roof against its gray roof counterpart, this actually is a go and has a positive value. I can also see this if I look at, say, the probability curve. So this actually shows the uncertainty around the value for whether we're looking at the blue line, which is the just hard dollar financial net present value, or if we incorporate the green line, if we look at the green line, which incorporates the social and environmental value as well, we can see that this has the potential of generating a very high positive value. So this is all to say that this kind of data can be really useful in supporting more sustainable design decisions that on the surface might look more expensive, but actually can save hard dollars over time, or can save soft dollars over time, or produce real value for society and the environment. And I'm going to go back into this life cycle cost analysis section here just to show one thing, which is that this green roof actually costs more money up front. But just to highlight this, the replacement cost, it actually produces more value over time. And the reason for that is that green roofs, as Eric mentioned in his presentation, can last up to twice as long or even more than their gray roof counterparts. So they have to be replaced much less frequently, and this can reduce costs down the line for the project owner. And so this is something that's really important to incorporate into the business case. The last thing I'll show you is the detailed results here. So, if you want to, and I won't go more in depth into this, but if you want to, you can actually look at each of the impacts, and you can look at the methodology and how it's working and the primary sources, and there's a link to the documentation. So if you want to, you can get really in depth, and you also have the ability to download a report. So you can just run an analysis, print it, and hand it to your client, or print the results. So that's kind of an overview of AutoCASE. And one thing I want to mention is that what I've shown you today is a couple different projects in what we're calling AutoCASE for green infrastructure. And as Eric mentioned, this is in beta. We're also going to be releasing another product that I'll just touch on for a second, which is called AutoCASE for sustainable buildings, along with a new landing page. So if you're interested, keep your eyes out for that, and that will be able to run a cost-benefit analysis on LEED credits. So we're trying to expand through all the different sectors of infrastructure as well as through the building space with triple bottom line and life cycle cost analysis. So that's it from my end, and I'm happy to take any questions or demo anything else that people want to see.
Ryan, can you talk at all about the Civil 3D and or InfraWorks 360 integration with AutoCASE?
Yep. So we have actually had 2 generations of plugins for InfraWorks 360 and for Civil 3D. And recently we actually prototyped another tool that integrates with AutoCAD and with Revit and Civil 3D and InfraWorks. So right now, those are not in the App Exchange, taking them down, and we're currently in the process of updating and refining those. So as we approach production releases in Q1 of next year, we expect to be also re-releasing plugins for InfraWorks and for Civil 3D, and hopefully for Revit and AutoCAD as well.
Okay, thanks. I believe are there videos out there or some way that folks can at least get a look at what's been done in the past, just to get some idea? Because I know there's some interest on this call with how your tool integrates with those 2 products. Are there resources out there that can get at least a peek at what that looks like?
Yep. Give me one sec. I can try to find a video. It might take me a moment, but yeah, I can definitely show a demo video of how that works.
Another question that came up: is there a published list of cities that you support?
That's a great question. How do you think about that? I actually don't think there is a published list of cities, but I can send you a list if you like, if you want to send to anybody on this call.
Okay. We've got a brief list of clients that we work with who are subscribers to AutoCASE on our website. That's autocase.com or impactinfrastructure.com. So AutoCASE has a long list of users, but so does the firm's consulting group as well, and we support clients to help run AutoCASE or conduct analyses on behalf of clients using AutoCASE. And we've worked with an extensive list of cities and organizations, utilities, large global companies, and we've analyzed about $50 billion worth of infrastructure over the last 7 or 8 years. So we've used this across infrastructure, the same cost-benefit, triple bottom line assessment to help inform projects. We work with federal, state, municipal, global organizations, and I think we've got a long track record, and AutoCASE is really the manifestation of all of that, and the ability for us to leverage the technology, the incredible work that's being done out there at Autodesk and in the market, and now we're able to automate these kinds of analyses as well. So it's a long list, and it's a growing list. It's very exciting to be a part of.
Great, thank you.
So Eric, can you see my screen? I should have a video up with InfoWorks 360 integration.
Yes, I can see it.
Okay. So I'll just play this. This is about 2 minutes, but this is the extension that we had in InfoWorks. So you were able to run a script in InfoWorks, and then AutoCASE would load a window where you'd actually be able to create a project within InfoWorks and import information from the drawing file. So I'll just kind of walk through this video as it goes. So here we're just stating the location of the project. So this was in Los Angeles, and then you can see it imports the city area, population, and housing information. The second part was enabling the user to import information from the design. So for this, the workflow that we used was to select a poly area around, or create a polyline around the site, which then selected all the design features, and you could then import all the design features into AutoCASE. So here you can see some of the design features have been labeled, some of them haven't, and we've also got some of the design features mapped in. So we know, some of these are managed turf. We know how many trees have been imported. We know some of the asphalt and stuff like that. After saving the inputs, you can then run the analysis. And this might look a little bit familiar, but this is basically using the detailed results section. So we've got all the different impacts from the project listed out here with a little description of the value of the project, breakdown of the value of this impact by design feature or object in the drawing file. And so this is kind of going through and showing that they're all kind of listed there. So that's looking at carbon emissions by vegetation. We've got capital costs, flood risk mitigation, and so on. So that kind of gives an idea of how this was working in InfoWorks. We found that there were some challenges with this, with consistency in the data that was being imported. So users were having to label each of the design features that were being imported a lot of the time and state what the type of design feature was. So that's why we've retracted this for now, because the workflow was, we thought, a little bit too clunky, and we're kind of in the process of refining that whole process before we re-release the plugins.
Okay, great. I think that takes care of all the questions we had up to this point. So I think what I'll do, Ryan, is I'm going to take back presenter.
Okay.
And I just want to take this last minute or two to remind everyone of our next webcast, which again is going to be InfoWorks 360 Component Roads and Super Elevation, Wednesday, October 5th from 12 to 1 Eastern. And watch for information and most importantly, a link to register for that webcast on the different sites that you see listed there, the community site, the discussion forum, as well as our various social media pages. And also, if you're a previous attendee of a webcast, you should get an email as well. But why wait for that? Go ahead and jump out into one of those listed locations below and look for that registration. That should be coming out in the next few days. So I just want to thank Eric and Ryan for the presentations today. They were really good and I think greatly received and enjoyed by everyone. I'm sure you guys are available if there are any questions. Folks know how to get a hold of me through email or through the discussion forum. So if anyone on the call has questions or if something pops up in your mind after today's presentation that you'd like to know more about, feel free to reach out to me and I will forward your question on to Eric and Ryan. So thanks again to you two for presenting, and thanks to everyone who attended. The session has been recorded, so it should be posted up to the community site within the next couple of days. So watch for that if you want to share it with somebody or or go back and review something that was covered. Thanks again. Have a great day, and we'll see y'all hopefully on October 5th. Thanks.